Calculate the packing efficiencies for simple cubic and body-centered cubic structures. Verify your answers by comparing them with the numbers given on page 245. Simple cubic with a packing efficiency of 52%. Before we can calculate volume of an atoms in a unit cell, how many atoms are contained in a simple cubic? Every atom at the corner is 1/8 of an atom. 1/8 times 8 is equal to 1. So, there are 1 atom per unit cell in a simple cubic structure. We can also derive at the formula number of atoms per unit cell is equal to 1/2 times the number simple atoms plus 1/8 times number of the corner atoms. A cube has 8 corners and 0 simple atoms, giving us 0 simple atoms and 8 center atoms. By using the formula, number of atoms per unit cell equals 1/2 times 0 is equal to 0, plus 1/8 times 8 is equal to 1, so 0 plus 1 is equal to 1 atom per unit cell. So each unit cell will contain 1 complete atom. If we let R be the radius of an atom, then the volume of each atom is 4/3 pi r cubed, so the total volume occupied by the atoms themselves is the number of atoms multiplied by the volume of each atom. To calculate the volume of one atom, we will going to multiply 1 atom times 4/3 pi r cubed, which is equal to 4/3 pi r cubed. Now, we just need to find the volume of the unit cell in terms of the radius of the atoms. Let A be the edge length of the cube. As shown in the figure I draw, we can see that the diagonal line through the center have a length of 1d. So, the edge length of the cube is equal to 2r. The volume of the cube is a cube. And now, we can express this in terms of r. Volume unit cell equals a cube is equal to 2r to the power of 3 is equal to 8r cubed. After that, combine this with the volume filled by atoms from the equation above. Now, we will find the packing efficiency, which we will derive to the formula. Packing efficiency is equal to volume of 1 atoms over volume of unit cell times 100. So, 4/3 pi r cubed divided by 8r cubed, and the answer will be multiplied to 100 is equal to 52.36% or 52%. Because we have confirmed that the result we gave earlier, it's easy to conclude that we have done the problem correctly. So let's proceed to the second one, the body-centered cube with a packing efficiency of 68%. As you can see, there are 2 atoms per unit cell. Every atom at the corner is 1/8 of an atom. So, 1/8 times number of corner atoms plus 1 whole atom at the center equals 1/8 times 8 is equal to 1 plus 1 is equal to 2. Therefore, there are 2 atoms per unit cell. After that, we will find the volume of 2 atoms, which is 2 atoms multiplied by 4/3 pi r cubed is equal to 8/3 pi r cubed. Next, we will find the edge length of an atom. So, here's sphere in here, a sphere at the bottom edge of a cube, and a sphere at the top edge. This sphere is twice the radius, which is the diameter, and this is r. Also, this is r. So, the distance between the bottom and top edge of a cube is 4r. So, let's see how can we relate. We know that every side of a cube is equal to a. Now, Let's call a diagonal between these 2 points. Let's call it L. This is different from the diagonal we want to find, which is where that's D. So notice that this is a right triangle at the bottom face of the cube, and so therefore we can say that L square equals A square plus A square. So now we need to draw another right triangle which has L as the base. This is the next hypotenuse. One of the leg is A, and hypotenuse of this triangle is the longest diagonal D. So focus on the triangle in green. L square plus A square is equal to the hypotenuse of D square. So in this equation, we need to replace L square with A square plus A square, and so we're gonna get this equation. So L square, which is the A square plus A square and plus the other A square, that's equal to D square. And so 3A square equals D square. Now, if we take the square roots of the both sides, the square root of 3A equals the left of the diagonal D. And the left of the diagonal is equal to 4R. To find the edge length of an atom, we will divide both sides by square root of 3 to eliminate the constant at the left side so that variable A will remain and we can find the edge length. So, after that, the edge length is equal to 4 over square root of 3R. Now that we finally get the edge length, we will proceed to the volume, which is the volume is A cube or the edge cube to the power of 3. So 4 over square root of 3R to the power of 3 is equal to 12.32 R cubed. Now, let's proceed to the packing efficiency, which we will derive to the formula volume of 2 atoms over volume of unit cell times 100. So, 8 over 3 pi R cubed, which is the volume of 2 atoms, over 12.32 R cubed, which is the volume of unit cell, times by 100 is equal to 68%. Now that I have confirmed the result, I conclude that we have done the problem correctly.